derivative would be 4x minus 8. Make it equal to 0. Move the 8 over, divide by 2, and you get x equals 2. That's going to be your critical point, 2 comma something. Now if I plug in a value less than 2 into my derivative, if I plug in 0 into my derivative, 4 times 0 minus 8 is a negative number. So that tells us that it is going down to begin with. And then after 2, if you plug in 15, 4 times 15 minus 8 is a positive number. Or you could choose 19 if we wanted to. That would work out as well. And then what we have here, 2 comma something, well, we plug in 2, we're going to get 8 minus 16 is negative 8, plus 5 is negative 3. So that's our critical point. And it is a minimum, right? Since the derivative is less than 0, I'll say before x equals 2 and f prime of x is bigger than 0 after x equals 2, we know at this point 2 comma negative 3 is a local minimum. And again, since it's a parabola, we know it's an absolute minimum in this case. So we can use calculus to find the x value, then plug it back into our original equation to find the y value for those minimums. We can also find maximum and minimum values with our calculator. Just need you to change one word here. This word intersect should be either max or min. We will go to y equals, clear things out. We'll type in this equation that we just did, which was 2x squared minus 8x plus 5. Take a look at that graph, see if it appears. And we can see the minimum. Sometimes you might have to change the window so that you can see it. And in order to calculate that, go second, the trace button, because above that is calculate. There is a maximum and a minimum button. This one is obviously a minimum, so go down to number 3. And then it will, the way the calculator figures this out is it asks you for what parameters do you want to find that minimum. So it asks you for a left bound first. Where my cursor is right now is left of the minimum. So if I push enter, it'll choose that. Now on the newer calculators, mine actually draws a vertical line in there for me. On the older ones, just an arrow shows up. And then you can either use the arrow keys to go over, but you might be clicking it for a while. Or if you can see a value, like 1, 2, 3, 4, I'm just going to put 4 in for my right bound. And it draws a dotted line there. Now my minimum is in between those two dotted lines. It always asks you to guess. So I think it's going to be here. Oh, I was off. I don't know why they ask you to guess. Maybe just to make sure that your lines were in the right place to begin with. And notice, what did we calculate as our minimum? It happened at 2. We know from calculus for sure that the answer is 2. And at negative 3. What your calculator is showing you here, and some of you might have a slightly different answer. Some of you might have 1.999. Some of you might have exactly 2. Okay, mine comes up as 2.000001. What the calculator is doing is it is doing a bunch of calculations and getting closer and closer and closer and closer and closer to the minimum. And once it reaches a certain amount of error that it's happy with, it stops. It's like, we're really close. So it's not, in this case, it's not perfectly accurate with your calculus. You are smarter than your calculator at this moment. Maybe you can't calculate as much, but you are smarter. Not faster. No, because the amount of calculations they did. Here we're crazy. All right.